So math can help us with real-world problems if we can develop a rough model for the situation. And basically what that means is we want to make an equation that roughly predicts the data. We'll never get it perfect because there's so many variables that make things change from one instance to the other. But that's what they want in part A, is to predict the time required. If you scroll over in your problem, we've got this equation where y, they said, is y's got to be distance, right? No, it says y is second. Sorry, I guess that makes sense because that's how much time has passed. So x is the distance they've run, and y is the time that's passed. So if we're asked to predict for a 600-meter race, that's a distance. So that's our x variable. That means they want you to plug 600 into this equation. In for x, because that's our x variable. I'll make that bigger for you. So I've replaced x with 600. So we got to do the order of operations, which means I have to multiply first. And then we can add the negative and the positive number there. So that's the same thing as subtracting 10.78. There we go. That's our prediction. For part B, use this model to predict the time for a 100-meter race. Actually, what else does it say here? Oh, it's given away. Well, I'm giving away the correct answers. Part 2 says, according to the relation, the time required for a 100-meter race is, that would be the same thing. You'd plug in 100 in for x and then simplify. Okay, so plug 100 instead of 600 in for x. And then for part 3, it says, wait. Oh, that's the same thing. Okay, so I don't know, part 2 and part 3 are the same thing. Part 4 says the time for a 100-meter race given by the relation. I don't know. So the time for a 100-meter race given by the relation blank. I don't know what they're saying. It's not. I guess the words they're looking for is that it's not. I don't know what the dropdown is, but it is not exactly the same as the data value given. That's what I was saying at the beginning. When we make a mathematical model, it's a rough approximation, but it's never exact, because in the real world, there's too many variables for us to make exact models. So this is a rough approximation, but it is not an exact relation between this variable and this variable, because there's some error. If you were to, like what we did was we plugged in if you were to plug in 100, you're not going to get 10.49 from your equation. You're going to get a prediction, something close to 10.49, but it's off by a bit, so it's not exact. This value is not exactly the same as the data value given in the table.